Hi, good afternoon, folks. Today I'm here to talk to you about the subsets of the real numbers. And the big idea here is that every number in this world can be classified as at least one special subset of the real numbers. So let's take a look at what each subset is and what it takes to be a number that's a part of that subset. All right, the first one we want to look at is the natural numbers. The symbol for the natural numbers is n. Okay, so the natural numbers, also known as the counting numbers, whose symbol is n, so that you don't have to write out the word every time. Well, again, if you think about counting numbers, if I told someone to count, let's see here, Chris, count for me. Well, I would say 1, 2, 3, 4, 5, 6, 7, 8. So if you wanted to say that a number is a counting number, it would have to be one of the numbers that are in this list. 1, 2, 3, 4, 5, yada, 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 right? Now, notice that counting numbers can't be fractions and can't be decimals. And the reason is, if you look at the other name or the actual real name for these numbers, it's the natural numbers. And the reason why we call them natural numbers is because these are the numbers that appear in nature. If I had a coconut tree, right, and it was producing coconuts, right, a coconut tree can produce 1 coconut, 2 coconuts, 3 coconuts, 4 coconuts, and so on, right? A coconut tree cannot produce a half a coconut or 2.5 coconuts. It either has a coconut or it doesn't have a coconut, right? So, counting numbers or natural numbers are numbers that appear in nature, and nature cannot produce a half of something. And that's why you can't have fractions in the counting numbers. Moreover, things in nature can't produce negative amounts. You can't have a tree produce a negative amount of coconuts. Therefore, negative numbers will not be counted as counting numbers or natural numbers. Now, and in fact, if you take IB, this definition will change slightly. The next idea we want to take a look at are the whole numbers. Their symbol is the letter W, so you don't have to write the word whole every time. If you notice, the difference between natural numbers and whole numbers, well, natural numbers start at 1 and go up. Whole numbers start at 0. So the only difference between a natural number and a whole number is the number 0. 0 is not a natural number, but it is considered a whole number. Now, that being said, my little device is whole numbers start at the whole. Get it? Whole numbers start at the whole, which is 0. Doesn't 0 look like a whole? So whole numbers are 0, 1, 2, 3, 4, 5, yada, 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 right? So it's important to note that anytime you have a natural number, you also have a whole number. The next subset that we want to look at is something called an integer. An integer, when you look at it, is all of the whole numbers, 0, 1, 2, 3, 4, 5, yada, 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 but they also include the negative values, -1, -2, -3, -4, and so on. But notice, since whole numbers can't be fractions or decimals, integers can't be fractions or decimals. So, every whole number, if you think about it, is also a set of the integers. So if I have a natural number, I know that natural number has to be a whole number, but since it's a whole number, it also has to be an integer. Okay? Then the next set of numbers that we look at are something called the rational numbers. And if you look at the word rational, the first 5 letters of the word rational spell the word ratio. And the word ratio just means fraction. So, a rational number is any number that can be written as a fraction. And now, when you think about decimals, decimals are a way of writing a fraction. However, only terminating decimals and repeating decimals can be written as a fraction. So for example, if I have 0.5, well, I know I can write that as a fraction of 1/2. If I have 0.3 repeating, remember that bar means that it's repeating, 0.33333, that can be written as a fraction as 1/3. So both terminating decimals and repeating decimals can be written as fractions. Therefore, they're rational numbers. Even if I have an integer like -5, now, even though that's not written as a fraction, it's very easy to take an integer, whole number, or natural number and change it into a rational number. I know that -5 is the same thing as -5 divided by 1. And now I see, oh, wait, that integer is also a rational number. So ultimately, what we know is that if I have any integer, whole number, or natural number, I know that I can also write those as a fraction, and therefore they must be rational. Notice that the symbol for rational is this Q. And the reason why they pick Q is Q comes from the word quotient. And we know a quotient means a division problem. Well, if I have 5 divided by 6, well, this fraction, 5 divided by 6, that's a quotient. And that's why we use the letter Q for rational. Now, the next set of numbers is called irrational numbers. And you should know that the prefix IR means not. So, for example, if I take the word responsible, we all know what responsible is, I hope. Well, if I add the prefix IR, irresponsible, that means that's the opposite of responsible. That's not responsible. So IR means the word not, right? So for irrational numbers means they're not rational. In other words, I cannot write them as a fraction. So what kind of numbers would I expect irrational numbers to be? Well, irrational numbers are numbers such as the square root of 5. Anytime you have a square root that's not a perfect square, that's going to be an irrational number. Because if I were to try to type this into my calculator, I would get some number 2 point yada 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 yada, and that decimal, it would go on forever. In other words, it would not terminate. But also, the pattern you would see would never repeat. So for irrational numbers, these are not terminating and not repeating. And again, the kind of numbers that would produce irrational numbers, again, are square root of 5, square root of 8, 1 plus the square root of 2 is irrational. And then there's a special one, pi. Pi is 3.14159. 159 ... That decimal never terminates and it never repeats. Therefore, we call it an irrational number. Okay, the next set, and this is the easiest set, is real number. Every number in our world is going to be a real number. Okay? And those are all the subsets of the real numbers that we have to consider. Now, it's important for you to note that anytime you're trying to consider whether a number is rational or real or whatever, you first have to figure out, can I simplify the number that I'm looking at? So always remember to try and simplify the problem before you decide what subset of the real numbers the number looks at. Like, for example, if I had, say, the square root of 49. Well, the square root of 49 simplifies to just 7. Now, if I were to figure out, hey, the square root of 49 is 7, well, what subsets of the real numbers does 7 belong to? Well, can I count to 7? Yeah, 1, 2, 3, 4, 5, 6, 7. 7 is part of the natural number, so I put an N there. Now, Is 7 a whole amount? Well, again, if you listen to the name whole, whole means no fractions or no decimals. 7 is definitely a whole amount, so it would be a whole number. Well, is 7 also going to be an integer? Well, we said that integers are always whole numbers and they're negatives. So I would say that 7, since it's a whole number, it must also be an integer. And then I come to rational. Well, can I write 7 as a fraction? Because that's what rational means. It means I can write it as a fraction. Well, 7 can easily be turned into a fraction by putting 7 over 1, and therefore it's rational. Now, it's important to note that rational numbers and irrational numbers, these are opposites. So if you belong to the rational numbers, it's impossible to also belong to the irrational numbers. Like, you cannot be responsible and irresponsible at the same time. You're either responsible or you're irresponsible, but not both. Similarly, if you put a number in the rational subset, you cannot say that it's also part of the irrational numbers. And then lastly, is 7 a real number? Does the number 7 appear in the real world? Well, yeah. Again, I can have, like for example, I have 7 fingers on my left hand. So, is 7 part of the real world? Yeah, so I'm going to put real there. So, the moral of the story, if you see an expression that can be simplified to say 7, I'm going to focus on the simplified version before I figure out what category it belongs to. All right, let's take a look at some of the examples out of your homework. Okay, so let's take a look at 13.2, repeating. All right, so here's the way I look at this. This is almost like a question bank. It can be natural, it can be whole, it can be integer, it can be rational, it can be irrational, it can be real. Well, I always like to start with the smallest group, the naturals. Now, can you count to 13.22 repeating? No. Again, if I started counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, you would not say 9, 10, 11, 12, 13, 13.2 repeating, 14. You would never say that, right? So I know that 13.2 repeating is not natural. Again, is this a whole amount? No, there's a decimal there. Whole amounts means no fractions, no decimals. Again, since integers are simply whole numbers and they're negatives, it's not an integer. But we said that rational numbers are any number that can be written as a fraction, and we said that repeating decimals can always be changed into a fraction. So 13.2 repeating, it would be rational. But since it's rational, you cannot be irrational because you can't be opposites. You can't belong to opposite groups. So you're rational, but you're not irrational. And then lastly, is it a real number? Yes, because every number in our world is real. So the reality is, you know that this answer of real is going to belong to every answer that you have. Now, if I wanted to order this by putting it on some number line, I know that 13.2 repeating has to be between 13 and 14. But because 13.2 repeating is closer to 13, I'm going to put a little dot on my number line, and I'm going to say that this number is 13.222 repeating, right? And so that's how I would order that number on a number line. Okay, so that's how we classify numbers according to what subset they belong to. Hopefully you get the idea of here. And again, in class on Monday, feel free to ask me any questions you might have. Now, if you take a look, I've also assigned problems out of the textbook. Now, what I've decided to do is, since some of us might have issues accessing the textbook, I'm going to go ahead and place on the Google Classroom a screenshot of these problems so that you can access them if you haven't already accessed them from a friend by taking a picture or not. Okay? But again, you know, I realize this is our first day back. If there's any issues, don't worry, we'll get them resolved. If you can do these problems, great, because of the textbook. If not, again, since it's the first